Hello everyone, good afternoon. I'm Hemalatha, myself, Assistant Professor in Physics from Laxman Reddy Institute of Technology and Management. So today's topic we are going to discuss is population inversion. We have discussed in the last class. So after population inversion, let us go for the types of mechanisms. You will be going for population inversion because to achieve population inversion, what is population inversion? Making more number of atoms to be present in the excited state. ఓకే కింద స్టేట్ కంటే పైన స్టేట్లో ఎక్కువ నెంబర్ ఆఫ్ ఆటమ్స్ని మనం వచ్చేట్టుగా చేయాలి. సో to make n2 greater than n1, we use certain mechanisms. So what are those mechanisms? They are called as pumping mechanisms. So what is pumping? In general, you can take the best example of a cycle tire or a vehicle tire, anything. If it loses air, there is loss of air in that one, then automatically the tire gets compressed. So in that case, we again pump the air. That means as the tire, once it is losing the air, it has come back to the initial state. Again, after pumping, it is coming back to its other state. That means raising of atoms is taking place. Excitation of atoms is taking place from one energy level to other energy level. So the process to make them excite from one energy level to other energy level, that is, for example, if you take two energy levels consisting of atoms as N1 and N2, then as the atoms are present in the lower energy state, by giving some energy, let us take in form of photons, then once these energy atoms present in the lower energy state, if they absorb the energy, they automatically get excited. So that process we call it as pumping process. So here you can see the definition. The process of supplying suitable form of energy to a system to achieve population inversion is called as pumping. So in order to produce the laser output, we require population inversion. So to get population inversion condition, we use the pumping methods. So there are several methods we are having here, and the things which are given in our syllabus are, one is optical pumping method. Okay, and this optical pumping method is particularly used in case of ruby laser. That is, in case of solid state lasers. Next, electrical discharge pumping method. This type of pumping methods generally we use in gaseous lasers. Next, inelastic atom collision pumping method. That is, in case of semiconductor laser, we'll be using this type of pumping. Then direct conversion pumping process. So these are the 4 different types of pumping process which are there in our syllabus. Now let us discuss each one in detail. Next, first is optical pumping methods. Now I hope you understood what is pumping. Pumping is nothing but raising the atoms from lower energy state to higher energy state. So that process we call it as pumping. And this is a pumping is used in order to achieve the condition of population inversion. Okay, now let us see the first method, that is the optical pumping method. Now, once if we supply suitable form of energy for the lower energy state atoms, then the lower energy state atoms absorbs the energy and they get excited to higher energy state. Now, once when they are jumping from lower energy state to higher energy state, that is nothing but, here we are going to see what is nothing but population inversion. So here the process of supplying suitable form of optical energy to a system to achieve population inversion is called as optical pumping. Okay, now in this method we will be using light source, normal light source. Let us take example of a ruby laser where we will be using a xenon flash lamp. A xenon flash lamp is a normal light source which will be in form of a normal LED light or the normal bulb. So that is supplying energy for the lower energy state atoms. Now, once that energy is absorbed by the lower energy state atoms, they are getting excited. So here we are writing, in this method, light source is used to supply energy in form of optical energy to excite the atoms from higher energy level, lower energy state to higher energy state to achieve population inversion. And generally this type of pumping is particularly used in solid state lasers. And the best example of solid state laser is ruby laser and Nd:YAG laser. Now, in case of ruby laser, if you take ruby laser, you can see the picture here, ruby laser, which is a solid state laser. That means the material, it is in form of a solid material, and that solid material to undergo excitation of atoms, here we are giving energy from a light source which is called as a xenon flash lamp. You can see the flash which is coming up. So that flash lamp is providing energy for the atoms in the lower energy state to get excited to higher energy state. So this type of pumping is called as optical pumping. Now next comes the electrical discharge pumping, which is also called as direct electron excitation. Directly we can make the excitation of electrons from lower energy state to higher energy states. Now this method, generally we will be applying a high voltage, or you can also use an electric field to both the electrodes. That means if you are having a discharge tube which is consisting of two electrodes, anode and the cathode, and this anode and cathode is connected to this voltage source, or you can connect an electric field, and this discharge tube which we are taking will be consisting of gaseous mixtures, because this type of pumping which is particularly used only for gaseous lasers. Now, once the electron, the discharge tube which is containing gas, then electrons are ejected from the cathode, accelerated towards the anode, and then collide with the gas molecules along the way. That means, for example, here I take the helium neon laser. Helium neon laser is a gaseous laser. Now this helium and neon, they are filled in a glass tube. To make you understand this type of pumping, I am telling you about helium neon laser. Helium neon laser is a gaseous laser. Now these two gases, they are filled in a glass tube. Now once we supply voltage, or once when we connect an electric field to the anode and cathode, that is the discharge tube, then automatically the first gas, helium, will absorb the energy from that anode, and then the electrons will get accelerated. Now these electrons which are getting accelerated, they move towards the other gas, that is the neon gas. Now in between this one, collision process is taking place. In between these two gases, once the helium supplies energy for the neon atoms, they get collided with each other, and at the collision process, the exchange of energy is taking place, which is giving rise to the neon atoms to get excited to higher energy states. So this type of pumping particularly used only in case of gaseous lasers. So here we are having the best examples, carbon dioxide gas laser and the helium neon gas laser in our syllabus. Next comes inelastic atom-atom collision pumping. Inelastic, we are not taking elastic materials, they are inelastic. That means once when they are moving away from their original state, they may come to their state or they may not come to their state. Such type of materials we call it as inelastic materials. So in this method, a combination of two types of gases are used, say for example A and B, both having same or nearly same energy, that is, which we call it as the excited states as A star and B star. In the first step, during the electric discharge, when discharge is released, what is discharge you may get? In your functions, you will be seeing that smoke will be released. Here also the discharge will be in form of that smoke only. Once that discharge is released, A gets excited to the higher energy state, that is the A star. And similarly, here, the other atom, that is B atom, once it receives energy, it also gets excited to the higher energy state B star. You can see in an equation form, E star, E electron plus atom giving rise to A star. Same, A star plus B. Why we are using here is collision is taking place because these two gases, these two atoms, they are in one state only. So the atom A will collide. The atom which is present in the higher energy state of A, that is A star, if it collides with the atom B, then automatically it gives rise to the B star atom plus A, because A is losing its energy. Next, direct conversion pumping method. What is this direct conversion pumping method? This is particularly used in case of PN junction diode. PN junction diode when it is in the forward biased condition. Why? Because in the forward biased condition, recombination of electrons and holes takes place across the junction. Once the recombination, that means both the electrons and holes which are near to the junction, they recombine with each other. Once the recombination is taking place means naturally they release some energy. Now this energy which is released is coming out in form of photons. So this type of method, we generally used in semiconductor lasers. Okay, so these are the 4 different types of pumping process which we have come up. First one is optical discharge pumping method. Second one is electric discharge pumping method. Third one is direct conversion pumping method. And fourth one is inelastic atom-to-atom collision pumping methods. We have more number of pumping also, but in our syllabus what we will be going is only for these type of pumping process. Now next let us come out. What is the block diagram of a laser? How does a laser look like? What are the different components of laser? Each and every laser system consists of 3 main parts. One is called as the source of energy, second one is the active medium, and third one is the optical resonator. You can see this figure. Now here, this is excitation mechanism. So for this excitation to produce, we require the source of energy. Either the source of energy may be in form of light source, or it may be in form of voltage source, or it may be in form of photons also. Any type of energy you can take. Now let us explain this one. Source of energy. Why do we require this source of energy? Now in order to make the lower energy state atoms get excited to higher energy state, we need to supply some energy. For different types of lasers, we use different pumping mechanisms. So this pumping mechanism is the basic thing which provides the energy for the lower energy state atoms. So to achieve population inversion, suitable form of energy must be supplied. So it supplies form of energy by using any one of the pumping mechanisms. For example, in case of ruby laser, xenon flash lamp, which we will be using in order to produce energy, that is in order to give excitation for the lower energy state atoms, the energy is supplied from the xenon flash lamp. So that is how you supply energy for the lower energy state atoms to jump from lower state to higher state. This is the first component, source of energy. Without source of energy, we cannot produce a laser output. So this is the first component. Second component is the active medium. Now you can see in case of a ruby laser, here we will be using, in case of the preparation of ruby laser, we will use 2 different type of components, that is 2 different types of metals. One is aluminum oxide, and this aluminum oxide is doped with some impurities which is called as chromium ions. Now this aluminum oxide which is doped with some impurities which is called as chromium ions. Now we are using 2 different elements. So in this one, which element is the active element which will be producing population inversion condition, or which will be producing the output of the ruby laser? So as in case of this ruby laser, aluminum oxide is a dummy material. It is just a dummy material. Now here chromium plays the major role in order to produce population inversion. So in case of ruby laser, what we say is chromium acts as the active center. Chromium is called as the active center, or you can also call it as the active element. Now if you go for helium and neon laser, that is a gaseous laser. In case of helium and neon laser, here helium is the supporting element. Helium is called as the dummy or the supporting element. Neon acts as the active center. Neon is called as the active element. Like that, in different types of lasers, different types of active centers will be present. Now, what is this active center? Which plays a major role in order to produce the condition of population inversion. So, that is in case of the ruby laser, chromium. In case of helium neon laser, neon material plays as the active element in case of this one. That is the second component. Now the third component, which is called as the optical resonator, or for producing the lasering action. Now let us see the figure of this one. You can see this figure. If you see this figure, here active medium is in between this one, and then excitation is produced for the atoms to undergo excitation from lower state to higher state. And if you observe this figure, at both the ends of this material, if you take a rod or if you take a glass tube, anything it may be, here we will be providing both the ends of the tube or the rod, we will be connecting two plano-convex lens. These plano-convex lens which acts as the optical resonator. Now, what is the purpose of this optical resonator? Now, if you take in case of a ruby laser, as I told you, chromium is called as the active element. So, chromium has to undergo population inversion condition. So, chromium has 3 energy levels. You can see chromium has 3 energy levels. Now, basically, chromium atoms will be present in the lower energy state. Now, we have given energy by using xenon flash lamp. So, once energy is supplied, automatically the chromium atoms jump to the higher energy state. That is the highest energy state is the third energy state. Now, once in this energy state, if the atom is not satisfying population inversion condition, then again it will be getting reverted back to the lower energy state. Now, in this process, this optical resonators will be used. That means once the atoms are undergoing collision with respect to each other or oscillations are taking place, the to and fro motion of electrons and atoms will be taking place. So, in this to and fro motion, the atoms which are satisfying the condition of population inversion, we call it as PI, population inversion. Once the atoms are satisfying population inversion, they will be coming out through the next end of the tube or the rod. The first end acts as a perfect reflector or the 100% reflector means all the reflections will be absorbed by this reflector. All the reflections means the atoms which are undergoing population inversion and the atoms which are not undergoing population inversion also, they will be taken by this, reflected by this 100% reflector. And the other end is a partial reflector, that is a 50% reflector. That means along this reflector, only the atoms which are satisfying this population inversion condition, they will be coming out. This is the purpose of optical resonator. So these are the 3 main components of a lasing system: source of energy, active medium, and the optical resonator. Okay, so this is about the components of the laser. Now next comes to what are the different types of lasers. We have in our syllabus 3 different types of lasers. One is solid state laser, second one is helium neon laser, third one is carbon dioxide laser. So let us go in detail with respect to these types of lasers, and this is a very important topic. Ruby laser. Ruby laser, generally it is a 3-level laser. It is called as a 3-level laser, which was being invented by Myanmar in 1960s. Now here, what is this one? Now, let us be simple. Let us go in a very simple manner. First, let us give what is the introduction, what we need to write for this ruby laser. Now, first point is, it is a solid state laser. I write it as solid state laser. First thing is, it is a solid state laser. Second thing is, it is a 3 energy level system. It has a 3 energy level system. Third thing is, what is the source of energy? That is the light source, what it is utilizing. Here it is utilizing the energy light source is xenon flash lamp. Xenon flash lamp is acting as a source of light. Now, fourth thing is here, what is the active center? Now, this is prepared basically by using Al2O3, that is aluminum oxide, and some of the aluminum atoms are replaced. That means some impurities are added in place of this aluminum. Those impurities are chromium ions. Now, in this one, chromium ions acts as the active centers. These materials which we are adding as the dopants, they are acting as the active centers in order to produce population inversion. Okay, next, active center. Next, an optical resonator. It has 2 sides of the rod has been provided with two plano-convex lens. One plano-convex lens is acting as the 100% reflector. Second plano-convex lens is acting as a 50% reflector. This is the introduction what we need to write. Now next, what is the construction of this ruby laser? Ruby laser is prepared by using aluminum oxide, Al2O3, and this aluminum oxide, some of the aluminum atoms have been replaced with chromium, and the chromium percentage is very, very less. That is 0.05% of doping is done in case of aluminum oxide. Now these chromium ions are generally in pink color. Now laser rods are prepared from a single crystal of pink ruby. Al2 does not participate in the lasing action. It only acts as a host. That's what I called it as a dummy material. It is a dummy thing. Only chromium plays the major role in producing the ruby laser. That is, in producing the laser output of a ruby material. Now, what are the dimensions of this one? The ruby laser, it is in form of a cylindrical one. Length of that rod is 2 centimeters to 30 centimeters. Depending on the application part, we take this one, and the diameter of that ruby rod, that is a cylindrical part, is 0.5 centimeters to 2 centimeters, and the ends of the ruby rod, they are polished, grounded, and made in flat position. The one end is completely silvered. That is a one part which we are calling it as a 100% reflector. It is coated with silver, and the other is also coated with silver to produce 50% reflector. Thus, the two polished ends acts as a optical resonating cavity. Now you can see this figure. Now this is a ruby rod, pink color one, purple color one. It is a ruby rod. This is placed in a glass tube. At both the ends of this ruby rod, we are having two lenses here, two optical resonating mirrors. One is called as a 100%. The other end is called as a partial reflector. Now around this one, we are using the xenon flash lamp, which is in form of a spiral binding one. And this spirally binded lamp is connected to an voltage source, which is called as the power. Okay, this is what the construction of ruby laser is. Now next, what I told now here, it is a helical flash lamp filled with xenon is used as a pumping source. The ruby crystal is placed inside the xenon flash lamp. Thus, optical pumping is used to achieve population inversion. Now, at very high temperatures is produced during the operation of laser. The rod is surrounded by liquid nitrogen to cool the apparatus. Why we are using this gray color one is in order to avoid high temperatures, to coolant the material, to coolant the apparatus, we are providing nitrogen gas that is filled with nitrogen gas. Now to explain this one, we require the energy level system. As I told you, ruby laser consists of 3 energy levels. Now let us name these 3 energy levels as, first one is called as G state, second one is called as M state, third one is called as H state. As we have already come across the metastable state in the last class. What is a metastable state? A state where we can show the condition of population inversion, where we can show that if I assume N1 is number of atoms, N2 number of atoms, N3 number of atoms, I can show the condition that N2 is greater than N1. So that condition we can show in the metastable state. Now here we are taking chromium ions. Chromium is consisting of a 3 energy level system. So they are named as G state, M state, and H state. So initially chromium ions are sitting in the lower energy state. Now the chromium ions are sitting in the lower energy state. Now these chromium ions, once the switch is on, the power source is on, the helium lamp, that is a xenon flash lamp, once it is switched on, then automatically it produces energy in form of heat. Now that heat energy is supplied to the chromium atoms which are present in the lower energy state. Now once the chromium ions receive the energy, they absorb that energy and they jump to the higher energy state. Here the higher energy state is the H state. So the atoms from the G state, they jump to H state. Okay, everyone should remember one point here. Here we are using xenon flash lamp flash. It is giving you the word flash. Flash means it produces energy in form of flashes, one flash after the other, as how you see your decoration lights. If you use different colors, you want to show the different colors. So one light of one color after the other color, how it comes out in form of flashes. Similarly, here also, xenon flash lamp is producing energy. It is giving energy in form of flashes. So one flash of energy is absorbed by the chromium ions, some part of the chromium ions, and they get excited to the higher energy state. And once after 10 seconds of time, a duration of time is given here. At 10 seconds of time, again it produces energy. And that energy is utilized by another number of chromium ions to undergo excitation process. Okay, this is how a cyclic process will go on because it is a flash lamp. After every 10 seconds of time, it produces the energy, and this energy is utilized by the lower energy state chromium atoms, and they get excited to the higher energy state. Now let us go to the higher energy state. Now, as in the previous classes, we have come across that in the higher energy state, atom will be staying for a time of 10 power minus 8 seconds. There is a specific time for the higher energy state atom, that is 10 power minus 8 seconds. The atoms will stay for a time of 10 power minus 8 seconds in the higher energy state. Once this lifetime is over, once this mean lifetime is completed, they automatically undergo de-excitation process by the process of spontaneous emission. Here we are not giving any energy to the higher energy state. Once their lifetime is completed, they are automatically getting de-excited to lower energy state. So this process, in the first part I told you, so this process, which is called as spontaneous emission process, it is undergoing. Now, as the chromium ions are getting energy, as they are rising to higher energy state, then once their lifetime is completed, they are getting de-excited to the middle state, that is, which is called as the M state. M state is called as the metastable state. It is called as the metastable state. Now, if you observe, in this metastable state, the atom stays for a time of 10 power minus 6 seconds. The atoms in this metastable state, they stay for a time of 10 power minus 6 seconds. You can see this one. This is 10 power minus 8, this is 10 power minus 6. A few seconds of time only, but that few seconds of time itself, more amount of population gets deposited in this M state. Once the more population is getting deposited, you can see that M is greater than G. M is greater than G. But here the condition what we need to say is, if you are giving energy, if you are supplying energy for 1/3 of chromium ions, if you are supplying energy for at a time for 1/3 chromium ions, if they jump to higher energy state, then only you can see the condition of population inversion, that is M greater than G. Okay, first we told in a general point. Next, I'm giving you the condition to see population inversion in case of ruby laser, that is, once the chromium ions receives, how much amount of percentage of chromium ions is 1/3 percentage of chromium ions. If they receive energy and they get excited to the higher energy state, you will observe that more number of atoms will be getting deposited in N state compared to that of the ground state. So this is nothing but, what is this condition? It is nothing but population inversion condition. Once if you are observing this condition, then automatically once the lifetime of 10 power minus 6 is completed, they de-excite to lower energy state by following the process of stimulated emission process. Once the lifetime is completed for some atoms, then automatically they undergo the process of stimulated emission, and the amount of output which is produced in this ruby laser is 6,943 Armstrongs of intensity of ruby laser light is emitted from this ruby laser. But there is one disadvantage in case of this ruby laser. That is, the output which is produced, it is coming out in form of a discontinuous output. Why it is coming out in form of a discontinuous output is, we are giving energy in form of flashes. So we are providing energy in form of flashes. So one flash after the other, it takes some duration of time. That's why the output which is produced is also not a continuous output. So this is one of the major disadvantage of a ruby laser. Now, in order to produce a continuous output, we are having the next type of laser, which is a gaseous laser, that is helium neon laser. I hope you have understood ruby laser. Very simple. Write the introduction. It is a solid state laser. It is a 3 energy level system. It has 3 energy level system. Next, it is prepared by aluminum oxide plus chromium ions, and the percentage of chromium ions is 0.05% of chromium ions is added. Now here the chromium plays as the active center role. Next, we are providing 2 plano-convex lens in order to produce an optical resonator. Now then come to the construction. Let us take the rod which is in form of a cylindrical part, and once this rod is spirally binded with the xenon flash lamp, then once you switch on the xenon flash lamp, energy is coming out in form of heat, and this energy is given used by the chromium ions. Now let us come to the working process. Once if you see the working process of this one, now the lower energy state, it has 3 energy levels. So let us name the lower energy state as the ground energy state. Let us name the second energy state as the what you call the middle energy state, which is called as the metastable state. Third, let us name that as the higher energy state. Now, once energy is given for the lower energy state chromium atoms, they absorb the energy and they get excited to the H state. Now, in the H state, they stay for a mean lifetime of 10 power minus 8 seconds. Once that time is completed, they are returning back to metastable state, that is the middle state. Now, in this state, they stay for a time of 10 power minus 6 seconds. Now, one condition here we apply is, if 1/3 population of atoms, that is 1/3 population of chromium ions, is pumped to higher energy state, then only we can observe population inversion in case of metastable state. That is, more atoms or more chromium ions get accumulated in M state when compared with that of the ground state. So that process we call it as a population inversion process. Then automatically once the lifetime is completed in M state, they get de-excited to the lower energy state, that is the ground state. In the ground state, they produce a laser output of 6,943 angstroms of intensified output is produced. But here this laser is not producing a continuous output. It is producing a discontinuous output. So, in order to provide a continuous output, we are going for helium neon laser. Now, what are the main things? What is the introduction? You can write in the simple manner. Here, type, it is a gaseous laser. What is the active medium? Here it is a mixture of helium and neon, and these two are taken in the ratio of 10:1. 10 helium atoms and 1 neon atom. And these two gases are filled in a glass tube. Now, active center is neon. Now, what type of pumping is used? Electric discharge pumping process is used. Now, optical resonator. So, here we are providing 2 plano-convex lens, concave mirrors. Now, what is the wavelength output which is produced? 6,328 nanometers of intensified output is produced. Now, number of levels involved in this energy level diagram is 4 energy levels. Now, what is the principle? The laser is based on the principle of stimulated emission produced in the active medium of the gas. What is the active medium? Neon is the active medium here. Okay, now you can see this diagram, you can easily follow this one. That introduction you write, and then you go for this figure. Now, this is a glass tube which is filled with 2 gases, helium and neon. Now, here as neon requires more amount of energy to enter into the glass tube, helium is used as a supporting element. Now, that is, if you fill helium, 10 helium atom energy is utilized for one neon atom to be filled in this glass tube. So that's why we are writing the ratio of these two gases in the ratio of 10:1. Helium is 10, neon is only one atom. So 10 atoms of helium is taking the energy, means only one atom of neon has pumped into the glass tube. Next, at both ends of the glass tube, two plano-concave mirrors are used in order to form the optical resonating cavity. Then here, in this one, here we are using a radio frequency oscillator. The type of pumping which we are using is the electric discharge pumping. So this electric discharge pumping, we use the optical resonator pumping, and that optical resonator will give energy in form of discharge. Once the discharge is released inside the glass tube, then automatically the helium ions which are present in the glass tube, they will collide with each other. Now the helium atom absorbs the energy initially, and then it collides with the neon atom. Now let us see what is the construction. The first gas laser to be operated successfully was helium neon laser in the year 1961 by the scientist Javan. In this method, they have used helium and neon which are in the ratio of 10:1, and they are being pumped into the glass tube in the quartz glass tube. Then the dimensions of the discharged glass tube are 80 centimeters length and 1.5 centimeters diameter with its windows slanted at Brewster angle. Why they are taking this Brewster angle is because it is a gas. So exploitation of gases takes place. So these are the specially designed windows which does not explode the gas. Then the purpose of placing is that one. Next, two plano-concave mirrors which are used as the dielectric materials in order to avoid exploitation of the gas. Next, what is the working principle? The discharge tube is filled inside the glass tube with the helium under a pressure of 1 mm of mercury and neon under a pressure of 0.1 mm of mercury. These two gases are filled inside that glass tube. Once discharge is released, then automatically the first gas is a helium gas. So helium absorbs energy and it gets excited to the higher energy state. Now helium has three energy levels. You can see helium has three energy levels named as E1. Helium has three energy levels, so they are named as F1, F2, F3. This is helium. Okay, now we provide energy for the lower energy state. Discharge is released, then helium absorbs the energy and get excited to higher energy state. Okay, similarly, as this is a 3 energy level system, neon has 4 energy levels, but here to explain population inversion, we show 5 energy levels because that ground energy state, we don't use that one. So here they are called as E0, E1, E2, E3, E4. Okay, one special property of this one is there here. Now what is that one is? Now here in case of this helium, helium has two energy levels, that is F2 and F3, which are called as metastable state. In this helium, it has two metastable states. Why? Because these two energy levels, they are having same energy. They are possessing same frequency and energy. The property of frequency and energy is the same. That's why these two energy levels are called as metastable states. That means here, once you give energy, for example, let us take 10 helium atoms are present in the lower energy state. Now from this 10 helium atoms, 5 will jump to F3 state. At the same time, 5 will jump to F2 state. That means as these two are having two same energies, so same number of atoms, once they undergo excitation with the energy, same number of atoms will be jumping to both the energy levels, that is F2 and F3. Now, through the process of collision, as the gases are present in a glass tube, through the process of collision, the helium atoms which are present in F2 and F3 states, they give energy for the neon atoms which are present in the lower energy state. Now, helium is having three energy levels named as F1, F2, F3. Now, in this helium, we are identifying two metastable states. They are named as F2 and F3. As they possess same frequency and energy, they are named as metastable states. So that means same number of atoms, once they absorb the energy, same number of atoms will be jumping from lower energy state to F2 and F3. Now these F2 and F3 ions, helium atoms, undergo collision with neon atoms and they give energy for the lower energy state neon atoms. Now along with helium, in neon also, two energy states, here they are identified as E4 and E2. E4 and E2, or if I take it in the textbooks, they have given it as E1, E2, E3, E4, E5. So they have given as E4 and E2, which are similar to, that is F3 is similar to E4, F2 is similar to E2. These two in neon, they are called as metastable states. That means equal number of atoms will be jumping to these energy states. Once the neon absorbs the energy, it jumps to higher energy state E5. Now, from E5 energy state, for example, 10 atoms are present in E5 energy state. Some 5 energy atoms are jumping to E4 state. At the same time, the 5 atoms will be jumping to E2 state. Now total 10 atoms, some atoms are jumping to E4, same number of atoms are also jumping to E2 state. Now the atoms which are jumping from the higher energy state to the next state, E5 and E4, they produces a radiation which is having an intensity of 3.39 micrometers. Now, next, at the same time, they are jumping to E2 state also, we told. Now, how do you produce a population inversion? Now, see here, that means here some atoms are jumping to E4 state. Now, the atoms which are present in the E4 state, some atoms will jump to E3 state. At the same time, some atoms will jump to E2 state. Why? Because they are metastable state. They possess same energy. That is the reason why the number of atoms which are jumping to E3 state, same number of atoms, they directly jump to E2 state also, where you can observe that more number of atoms are present in the lower energy state when more number of atoms are present in the higher energy state when compared with that of lower energy state. N2 is greater than N1. See here, very simple. Here F3 and F2 are called as metastable state. Similarly, in case of neon also, two metastable states are identified, that is E4 and E2. That means equal excitation of atoms will be taking place for these two energy states. Now from E4, it is jumping, some are jumping to E3, at the same time some are directly jumping to E2. So you can observe more population is present in E2 when compared with that of the lower energy state. So this process where we say that population inversion is achieved. So here the transition which is undergoing from E5 state to E4 state, it produces a wavelength of 3.39 micrometers. At the same time, the the excitation undergoing from E3 state to E2 state, it also produces a wavelength of 1.15 micrometers. Now you can see the actual wavelength which is produced is, here, the actual wavelength will be produced in the energy state of E2, that is 6328 nanometers of wavelength is produced in this one, which produces a continuous wave output. That's why gaseous lasers are used in welding process, cutting process. All the gas lasers are the very important lasers which are used in major applications. Now, for all these content, I have used these two reference books. One reference book is a textbook of solid state physics by Palaniswamy, which is a famous book. And then the second book is a textbook of applied physics, which has been published by Spectrum Publications. Okay, thank you. In the next class, I will tell you about optical fibers. Thank you.